All right, so today we're looking at April 8th. So we're on data structures part 2. Um, and so today we're going to go over programming assignment 9. Just get that assigned out so that if you have any questions, you can let me know, and then that is due in a week. Okay. All right, so, well, it's actually going to be easier if I go into the web. So yeah, okay, so programming assignment 9 is using a stack. Okay, assignment 9. All right, so Java program, you're basically writing a validator for a Java program. Okay, so a Java program contains various pairs of grouping symbols such as parentheses, braces, and brackets. Okay. Note that the grouping symbols cannot overlap, and you see the example there. So where it's kind of interleaved, where you have a parentheses, the letter a brace, a parentheses. So that is illegal. So what you want to do is you want to write a program to check whether a Java source code file has correct pairs of grouping symbols. Okay, a Java source code program. So the goal of this assignment is to begin understanding collections. In order to get credit for the assignment, you must use a stack. Okay, so it's not just, it's kind of like the last assignment with recursion. It's not just about completing the assignment, it's about using the tool that the assignment specifies. And in this case, it's a stack. Okay. So what you're going to do is you're going to ask the user to enter the file name along with its full path to read in the file. The string input should be used to create a file object. Excuse me. Okay. So you'll do like a scanner, where you scan in the input, that type of thing. But the input will be a string, but the string will actually be a file path. Okay. Then you will use that file path to then create a Java file object. Okay. And then that will allow you to do certain things on it. Is it a file? Is it not a file? Is it a directory? Those things. But anyways, once you have a file object that is valid, you can use, there's a couple different ways you can do it, but you want to basically read that file line by line. Okay, you want to read it line by line, and then look at the characters, like character by character on the line. Okay. And so then I have some rules here for you. So if it is a opening parentheses, opening brace, or opening bracket, then you push it to the stack. If the string is a closing parentheses, a closing brace, or a closing bracket, then pop from the stack. Okay. That sounds simple, and it is. But one other thing that you have to keep in mind is you don't just pop off the stack if you see an opening bracket. You have to make sure that you don't run into this case. So in this case, if you were going through just with those simple rules, what would happen is you would see this, you would push it to the stack, you would see this, you would push it to the stack, you would see this, and you would pop from the stack, and you'd see this, and you'd pop from the stack. And since your stack would be empty, it would look like you have a valid program. So what you have to make sure is that if you push this to the stack, push this to the stack, and you see a closing brace, bracket, or parentheses, you have to make sure that what is on top of the stack actually is the matching one. Okay, it actually is the matching. It actually is an opening parentheses, not an opening brace. Okay. If you don't do that, then your program will validate invalid programs. Okay, so just keep that in mind. And then when the end of the file is reached, if the stack is empty, then the file has the correct pairs of grouping symbols. Otherwise, the grouping symbols are not balanced. And then just throw an error or print a message to the user to show what's going on. Okay. So probably the hard part of this assignment, if you haven't done much with files, is going to be to create files and read from files and that type of thing. But we have examples within here, and you have done an assignment with one. So this shows you how to create a file, create a scanner for the file, and then input.next. This is what you're going to be taking in from the user. So a string that represents some sort of text, some sort of file path that they can then that you can then take and create a file object from. Okay. So that's what you'll be taking from the user to make sure that you make sure that you've tested it well. So I don't have any within the assignment 9 package. I don't have any starter files. So be sure to create a new file. You can call it, Java program validator or something like that. Just give it a name that makes sense, and then create a main method in there and do your program. You can do all of your program in one file in one main method, or you can create objects. However you want to do it, just make sure that you have a main method that will execute and follow the instructions. Okay. Questions? All right. All right, so that is assignment 9. That is your final assignment. I know that feels good. So that is due in 1 week, and then that's due in 1 week, and then data structures this week, and we'll do test review on Friday because your tests will be Monday. Remember, for your test, make sure you have the ability to print and the ability to scan. Okay. Today it will be your last day to let me know if you don't have those abilities. Okay. So make sure you have the ability to print and the ability to scan. Like I said, I'm not too concerned about scanning. There's a lot of iPhone apps that allow you to scan and email from it and create a PDF from an app. I'm not too concerned about scanning. One I use is called Genius Scan. It's free on iPhone. But what I can't control is if you can't print. So make sure you have the ability to print and scan. Let me know today if you can't. Okay. That will be required for test 3. So test 3, you'll have 50 minutes to complete it. I'm going to give you like an hour or maybe an hour and 5 or something like that, so that you have time on the front end to print it, 50 minutes to do it, and then time on the end to do the scanning and submit it to me. Okay. And then next class, I'll show you how we'll get that submitted. Probably a link in SitLearn so that you can actually submit it that way. Okay. All right, I'm running a little short on time, but I'm going to run through these slides real quick. So this is part 2 of data structures. So we're just going to dig right in. So what is a data structure? What is the definition of a data structure? Data structure is a collection of data organized in some fashion. Okay. The structure not only stores data, but also supports operations for accessing and manipulating the data. Okay, so that is very, very high level. With that definition, you could technically call a database a data structure, but in computer science, it is well known that a data structure is something that is within memory, something that you use within memory that is not persistent. Okay, so just keep that in mind, but that is a good definition for a data structure. A collection, so you have the Java collection framework, and a collection is a container object that holds a group of objects. Within Java, they often call them elements. And then there's 3 types of collections: lists, sets, and maps. And then here is kind of the framework for all of those hierarchies. So collection encapsulates everything, okay? It encapsulates all of them. So then under that, you have set, list, queue, and then it doesn't show, but there's map as well. And so you have your list framework that goes to abstract list, and you have vector, array list, and linked list, and then also like a sequential list. So that's why I recommend, if you need to preserve the ordering, the ordering of elements in which you add to a list, or you need to use a linked list. An array list will generally keep the order, but since linked list actually extends from a sequential list, that is going to be your best bet for making sure that you can keep order. Not always does that happen, okay? And then you have stack, linked hash sets, and then tree sets. And we'll get into sets. But the main thing that a set does, and we'll get in that, is it does not allow duplicates. Okay, so if you have a list of 1,000 elements and you want to make sure that you don't have duplicates, the easy way is to just transform that list into a set, and the set framework will automatically remove duplicates. So it's kind of cool to know, but anyways. So anyways, this is just kind of a high level of the Java framework. Okay, so here's the collections interface. I'm not going to dig into this too much, but you have your basic methods, where it's add, where you add an element, add all, where you can add an existing collection to another collection. Clear will empty it. It will basically wipe everything. Contains returns true if it will contains the object that you pass in. Contains all returns true or false depending on if it contains the entire collection that you pass in. Is empty returns true or false and determines if the list or the collection is true empty. Remove an object, remove an entire collection of objects, and then retain all elements. Retains the elements that are both in C and in this collection. So that is kind of like a union operation, if you will. Size, returns just integer, the size of it. To array, there's sometimes within Java that you need an actual old school array. You can't operate with a Java framework collection object. So they actually have created a to array method, which will send everything to an array, and then that will return an array. Stream and then parallel stream, that's Java 8 stuff. We'll cover that later. Okay. All right, so the list interface. The list stores elements in a sequential order and allows the user to specify where the elements is stored. The user can access the elements by index. First sentence is a little misleading, okay? So for an array list, that's not always the case, but I see what they're getting at. But the fact that user can specify where the elements are stored and the user can access the elements by index is true. So this is the list interface. This is more in line with the old school array. So that's probably why we use lists more frequently, is because if you've learned Java or any kind of programming language on arrays, then the list interface mimics the arrays, because you have kind of the same thing. You can add an element at a certain index. You can add all, like a whole collection, at a certain index. You can get an element at an index. You can determine the index of an element, returns an integer. Last index iterator. You can remove an index, and it will actually return the element that was removed. Set an element and create a sublist. So you have this concept of index, which you're used to working with arrays. So that's why we gravitate toward the list interface. And the list iterator. So an iterator, it basically is a way to iterate over a list, but it's outside of the list. So one example that I use sometimes is if you were doing a for loop over a list to remove duplicates, what you would probably do within that for loop is if you found something that was a duplicate, you would remove it. The issue is that within a for loop, you're probably iterating over an existing loop. It's iterating over the list itself. You can't remove because it will mess up your for loop. So you get this weird like pointer error. So an iterator allows you to step outside of the list that you're wanting to walk through, and then it will tell you, it'll allow you to add elements, determine if it has a previous element, if it has a next index, previous index, and set. So it allows you to basically an object walk through and back to a list. So it's a very powerful tool. They're not used as frequently now since Java has used functional streams and those type of things. Okay. So underneath the two lists, the list interface is two implementations of lists, and those are array list and linked list. So list is the interface, and the implementations are these two. Okay, so you have the array list, and linked list, and they're the concrete implementations of the list interfaces. So which of the two you use depends on your specific needs. Okay, so if you need to support random access, so I will be jumping around my array list or my list, accessing different elements at different indexes frequently, then you would use an array list. Now that doesn't mean that you can't do that with a linked list, because they both in fact are subclasses of the list interface. But it means that the array list implementation is going to be much more efficient. Okay, it's going to be much more efficient because what you're doing is on the back end of an array list is I think an actual array, so it mimics an array. So random access is very, very quick. However, 99% of the time, a lot of your applications, what you're doing is you're just adding to a list and you're removing from a list. You're adding to a list and removing to a list. Those applications it would be much faster to use a linked list. And essentially a linked list is think of a train of objects where you have a pointer to the one before it and a pointer to the one previous to it. So you're not actually using an array on the back end. The reason why that is actually much more efficient is, think again of an array. An array, you have to have an initial capacity, and as soon as you reach that capacity, you have to basically copy all the elements to a new array of larger size and then delete the old array. So if you're adding a lot of elements frequently to an array list, all of that has to happen on the back end. So you're constantly creating new arrays that are larger. You're constantly adding them to a new, and so there's a lot of overhead. However, for a linked list, if you're adding a lot of elements, it's literally just new object, new pointer, new object, new pointer, new object, new pointer, and you can grow exponent. I mean, you can grow as large as you want to, and there won't be an overhead in a lot of additions. And same thing for deletions as well. So you're just basically pulling one off the top or whatever, and you're deleting it. The downside of the linked list is if you're trying to do random access, an array list, if you want to access element 2000, it's literally going boom, element 2000, because I have that already in memory. For linked lists, what you have to do is actually traverse 2000 times to get to the 2000 element, because it is just a chain of pointers. So that's the downside of the array list when it comes to random access. So both of which have have very good pros and cons, but it's not one that's better than the other. It's basically looking at your situation, looking at your program, and seeing what is happening in this particular program that you're doing, and which data structure will fit that situation. Okay. And this is the slides on that. So lists can grow and shrink dynamically. An array is fixed once it is created. If your application does not require insertion or deletion of elements, the most efficient data structure is the array. Correct. And then this is the implementation of, this is just the constructors for an array list. And then this is the different methods on top of the list interface that you can do for a linked list. You can do add first, add last, remove first, remove last, get first, get last. Okay, so those are in addition to the list interface methods. Test array and linked lists. And then the comparator, we've talked about that. I think. There's collections you know. So we're going to cut it. I'm going to tell you we've been doing like 30-minute classes. We'll cover that next class because I want to get in and look at the actual. I want to dig in and actually show you the comparators and the list and that type of thing. The good news is next class we'll be doing some test review, and I'll review anything you need. And then we got a lot of review classes, so we got plenty of time to catch up on this stuff before your final. And then also we'll go through the programming assignment workshop week. Okay. Questions?
Oh yeah, I actually had a question.
Yeah, go ahead.
So if an array has an index associated for each like item, how come it can be like not ordered sometimes?
Say it again, sorry.
If an array has an index for each like item, then how come sometimes it can be out of order?
So not an array, but an array
list.
And the reason why I make that distinction is because an array list uses an array on the background behind it, but sometimes, and I'm not sure, but sometimes within Java's framework, they do something. I don't know, but there has been times when I've used array lists in professional instances where it almost like it. I think what happens is when it creates that new array. So say you have an array of 10 on the back end of an array list, and then you hit that 11th element. And I think what happens is on the copy to the new array, something happens and they get out of order. I think, and I may be complete, and I can look up this, but I've just noticed that the array list implementation does not always guarantee order. But an array, if you use like an old school array directly, obviously you can control order because you have that index within them. I can get back to you and give a much better answer to that. But that's the distinction I would make. Okay. Any questions? That's a good question, actually. Okay. Yeah, let me get back to you on that answer. And make sure that I have that ironed out. But I do know that there's a difference. There's a reason why linked list inherits from the abstract sequential list, and it's to guarantee any kind of sequential adding. But I'll get back to that. So yeah, next class we'll do test review. So be prepared for that, and then test 3 on Monday. But if there is no other questions, I'll see you guys Friday. We good? Looks like it. All right. See you guys Friday.